Before gonna get started with sampling variability and all the statistical formula and calculations, I would like to mention that the sampling variability, why we're talking about sampling variability here. Sampling variability means, when you sample certain number of data from the entire population, for example, okay, let's say you pick 10 people from this entire population, then you get certain data, like for example the average, mean, and you pick a different sample group, of let's say 10 people, and you get similar but slightly different, statistical data, like mean could be pretty similar but could be different, slightly different, and you pick a different a group of 10 people from this entire population, and you get slightly different data. All these samples have similar data, but they're slightly different from each other. These differences, or what we call, error, standard error, because when we get the data or parameter from the population, we know the exact mean, for example, exact average of the entire population, for example, or whatever it is, mode, median, whatever. But when we get samples from different, when we sample different groups from the same population, the value is going to be different. Let's just talk about the mean for now. Population mean, let's say it's 50, and you sample just 10 people from the population, and you get the mean, and it could be 48.5 or 49.5 or something. And if you pick a different sample, then the mean from the sample could be 51.2, for example. They're close to, they're really similar, but you understand, right? In reality, each time you pick different samples, you're not gonna get the same value, because you can't pick the same people or same numbers, each time. The samples you gather have slightly different characteristics each time, because you're not like a god and you can always pick the same samples. You can't do that. Or you can just pick the same samples with the same values. You cannot do that. So that's a random chances working and going on, and unfortunately this time from this sample the mean was 51.2, for example, and the next time you pick different sample, the mean could be 52.5 something, or 48 point something. It's kind of around the mean, but each time it's different. And such variability, or kind of what we call standard error, exists. So it's the same population. It's the same population, just we're looking at the different portion of the population, different sample. We're looking at different samples, and basically, we're talking about the same population, but depending on which sample you get, you may get slightly different values. And these errors, margin of errors, the margin of errors exist. So as long as it's within margin of error, we can say, it's the same population, it's the same thing. We're talking about the same population. We're talking about, it's the same population, it's the same thing. The error, margin of error exists, in nature. So, you can't help, but basically what we're saying is, you're getting the sample, getting the value from the same sample. You're talking about the same population. You get the sample from here, get sample from there, get sample from there, and you get different values, but these values are so close to each other, differences are so small, it's within the margin of error. And so it's you know, it's always an margin of the marginal error exists, in nature. So we can say, oh, these values are different, but hey, it's so small, it's within the margin of error. So we're talking about the same thing. We're talking about the same group, same population, same distribution. That's the idea. So, the point is the margin of error. What's the margin of error? So what we're trying to do is we're trying to determine. We know that there's a margin of error, and what we're trying to determine is if the population is the same, if the population hasn't changed at all, if you're talking about the same population with the same characteristics and everything, then how much margin of error exists? How much standard error exists within the same population if there's no change in the population, but still there's an error? How much standard error exists in the population? When you pick from the same population, that's gonna be always different each time, and we're trying to determine how much standard error exists within the same population. This is useful when we do research.